Hello, welcome back. This is my fifth video of chapter Sequences and Series of Standard 11 Mathematics NCERT textbook. Today we can discuss exercise 9.2, exercise on arithmetic progression. Okay, we can go to the video. Before that, if you are watching this channel without subscribing, please do subscribe. Okay, first question, find the sum of odd integers from 1 to 2001. We have to find the sum of odd integers from 1 to 2001. What will be the sequence here? Here the first term is 1, then odd integers. The next term will be 3, 5, 7, etc. up to 2001. See, here A is equal to 1. D is equal to, common difference D is equal to 3 minus 1, 2 or 5 minus 3, 2. And what is the last term here? Last term is equal to 2001. What's the equation for sum to n terms? Sn is equal to n by 2 into a plus l. Or n by 2 into 2a plus n minus 1 into d. Okay, we can see by this equation. Then I will show the other one also. Okay. Here we need n. We have the last term L is equal to 2001 or nth term is equal to 2001. Or we can write an is equal to, what's the equation for the last term or nth term? A plus n minus 1 into d. Here last term is 2001. 2001 is equal to, what is A? 1 plus n minus 1 into, what is D? 2. Which is equal to 1 plus 2n minus 2. That is 2n, 1 minus 2 is minus 1. 2n minus 1. Or 2001 plus 1 is equal to 2n. That is 2n is equal to 2001 plus 1, that is 2002. That is n is equal to 1001. 2002 by 2, which is equal to 1001. That is, we have got n. Now we can substitute in this equation. This will become 1001 by 2 into a plus l. A is 1, l is 2001. 1 plus 2001, which is 2002. That is 1001 into 2002 by 2 is again 1001. That is 1001 square, which will be equal to 1002001. This will be the answer. Or if you are taking the equation Sn is equal to n by 2 into 2a plus n minus 1 into d. Here you have a, you got n, which is equal to 1001 by 2 into a is 1. That is 2 into 1 plus n minus 1 is 1001 minus 1. That is 1000 into d. d is 2. Just substitute, expand. Which is 1001. Now 2 plus 1000 into 2 is 2000. 2000 plus 2 is 2002. Divided by 2 is again 1001, which is equal to 1002001. So the formula for sum to n terms is very important. You have to remember this equation or this one. Second question is, find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5. Here also we have to find the sum. See here the arithmetic progression is the numbers lying between 100 and 1000 and multiples of 5. Multiples of 5 between 100 and 1000. Since it is lying between 100 and 1000, we need not to consider 100 and 1000. The numbers between them. See, what will be the first term? 105. Next 110, 115, etc. What will be the last term? 1000 minus 5, that is 995. So this is the AP. Here A is equal to 105, D is equal to 5, and last term L is equal to 995. So what is Sn? Sn is equal to n by 2 into A plus L, or n by 2 into 2A plus n minus 1 into D. You can use any of this equation. So we need n here. We have L is equal to 995. That is An is equal to last term, nth term is equal to 995. That is A plus n minus 1 into D is equal to 995. Here A is equal to 105 plus n minus 1 into 5 is equal to 995. That is, take 105 to this side. 5n minus 5 is equal to 995 minus 105, which is equal to 890. That is 5n is equal to 895. Take 5 to the side, that is 895. Therefore n is equal to 895 by 5, which is equal to 179. So we have n. Now substitute to this formula. Sn is equal to 179 by 2 into A is equal to 105 plus L is equal to 995, which is equal to 179 by 2 into 105 plus 995 is equal to 1100, which is equal to 1100 by 2 is 550. That is 179 into 550. You can use calculator from this step onwards, which will be equal to. Therefore, this is the answer. Next question. In an AP, the first term is 2 and the sum of the first 5 terms is 1/4 of the next 5 terms. Show that 20th term is. We have the first term is A is equal to 2 and the sum of the first 5 terms is 1/4 of the next 5 terms. What is sum of first 5 terms? If A1, A2, A3 etc. is the AP, then S5 is equal to A1 plus A2 plus etc. plus A5. And what is the sum of next 5 terms? Next 5 terms is A6 plus A7 plus etc. plus A10. That is S10 minus S5. S10 is A1 plus etc. plus A10. S10 minus S5 is next sum of next 5 terms. This is equal to S10 minus S5. Here given sum of the first 5 terms is 1/4 of the next 5 terms. That is, given S5 is equal to 1/4 of next sum of next 5 terms. That is S10 minus S5. This is given. S5 is equal to 1/4 into S10 minus S5. We have to find out 20th term. Show that 20th term is, we have to get A20 is equal to minus 112. We have given S5 is equal to 1/4 into S10 minus S5. S5 is equal to 1/4 into S10 minus S5. What is the equation for sum to n terms? Sn is equal to, here, n by 2 into 2a plus n minus 1 into d. Here take S5 together this side. This will become 4 into S5 plus S5. That is 5S5 is equal to S10. Now substitute for Sn. 5 into S5 is equal to 5/2 into 2a plus 4d. 5/2 into 2a plus 4d, and S10 is equal to 10 by 2 into 2a plus 9d. A is equal to 2. Solving this, we will get the common difference. Then it's easy to find the 20th term. Here this is 25 by 2 into A is equal to 2. 2 into 2 is equal to 4. 4 plus 4d is equal to, this is 10 by 2 into 4 plus 9d. Here we can cancel 1 by 2 both sides. This is, now we can take the terms with the d to the side and other numbers to the side. Here 25 into 4d is equal to 100d minus 10 into 9d is equal to 90d, which is equal to 10 into 4 is equal to 40 minus 25 into 400. That is 10d is equal to 40 minus 100 is equal to minus 60, implies d is equal to minus 60 by 10 is equal to minus 6. So we have d. Now to find A20 is equal to a plus 19d. Here a is equal to 2. 2 plus 19 into minus 6, which will be equal to minus 112. So A20 is equal to minus 112. Next question. How many terms of the AP minus 6, minus 11 by 2, minus 5, etc. are needed to give the sum minus 25? Here A is given, we can find out the common difference. Second term is also given, so we can find the common difference easily. And Sn is given, we have to find n. Here A is equal to minus 6, D is equal to second term minus first term, minus 11 by 2 minus 6, which is equal to, here 2 into 6 is equal to 12 minus 11 is equal to 1 by 2. D is equal to 1 by 2. And Sn is also given, which is equal to minus 25. We have to find n. We know the equation for Sn is equal to n by 2 into 2a plus n minus 1 into d, which is equal to minus 25 given. That is n by 2 into, substitute for a and d. 2 into minus 6 is equal to minus 12 plus n minus 1 into d is equal to 1 by 2 is equal to minus 25. This is n by 2 into, here 2 into minus 12 is equal to minus 24 plus n minus 1 by 2 is equal to minus 25. This is, take this 2 into 2 to the side, that is minus 25 into 4, that is minus 100. Now minus 24n plus n into n minus 1, that is n square minus n is equal to minus 100. Minus 25 into 400, that is n square minus 24n minus n is equal to minus 25n. Minus 100 taking to the side, it will become plus 100 is equal to 0. So we have a quadratic equation. You can easily solve this quadratic equation to get n is equal to 5 or 20. So sum of first 5 terms will be minus 25, and again taking 20 terms, sum to 20 terms will also be minus 25. So n is equal to 5 or 20. You can solve this by using the equation minus b plus or minus root of b square minus 4ac by 2a. Here a is equal to 1, b is equal to minus 25, and c is equal to 100.
Fifth question. In an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first p into q terms is 1 by 2 into pq plus 1, where p not equal to q. Given pth term and qth term, that is AP and AQ are given. That is AP is equal to 1 by Q and AQ is equal to 1 by P. We have to prove that sum of first PQ terms, that is we have to prove SPQ is equal to 1 by 2 into PQ plus 1. This is the question. Prove that SPQ is equal to 1 by 2 into PQ plus 1. So, what is a pth term? The formula for pth term A plus P minus 1 into D. That is A plus P minus 1 into D is equal to 1 by Q. And A plus AQ is equal to A plus Q minus 1 into D. A plus Q minus 1 into D is equal to 1 by P. Let it be first equation and this one second. Now solving first and second equation, we will get the common difference D. Here we can do 1 minus 2. See, 1 minus 2 implies A plus P minus 1 into D minus A plus Q minus 1 into D. That is A minus A. 0 get cancelled. Now P minus 1 into D minus Q minus 1 into D. That is D into P minus 1 minus of Q minus 1. That is minus of Q minus 1 is equal to 1 by Q minus 1 by P. See, P minus 1 minus Q plus 1, that is minus 1 plus 1 is equal to 0, get cancelled. That is D into P minus Q is equal to, this is denominator, take denominator LCM of P and Q, that is P into Q, which will become P minus Q by P into Q. Here P minus Q get cancelled, or it will become P minus Q by P minus Q, which is equal to 1. Implies D is equal to 1 by P into Q. Now we have D 1 by PQ. To get A first term, we can substitute in 1 or 2. Now 1 implies A plus P minus 1 into D is equal to 1 by PQ is equal to 1 by Q. That is A is equal to 1 by Q minus P minus 1 by PQ, which is equal to, here multiply by P to make the same denominator. This is P by PQ minus P minus 1 by PQ, which is equal to P minus of P minus 1 by PQ, that is P minus P plus 1 by PQ, that is 1 by PQ. So we have A is equal to 1 by PQ and D is equal to 1 by PQ. We have to prove SPQ is equal to 1 by 2 into PQ plus 1. Now what is the formula for Sn? Sn is equal to n by 2 into 2a plus n minus 1 into d. Here instead of n, p into q. Therefore SPQ is equal to PQ by 2 into 2a. A is equal to 1 by PQ, that is 2 by PQ plus n minus 1. Instead of n, p into q. PQ minus 1 into d is equal to 1 by PQ, which is equal to, here PQ same denominator, therefore 2 plus PQ minus 1 by PQ. PQ gets cancelled. That is 1 by 2 into 2 plus PQ minus 1. 2 minus 1 is equal to 1. That is 1 by 2 into PQ plus 1. This is we have to prove. SPQ is equal to 1 by 2 into PQ plus 1. SPQ is equal to 1 by 2 into PQ plus 1.